Okay, so we are on lesson 2.4 and we are going to, oh no, this is not big enough. We're going to be moving on to the next little understanding. Oh, there it goes. Oh, that's why. Okay, so here's the very first problem. It says find the missing terms in the geometric sequence, blah, blah, blah. Write an explicit term for the geometric sequence. I already looked at this. I'm pretty impressed with what my buddies over here have. So I'm just going to look at a couple. Ooh, look at all these jumps. I don't believe you. And then you check. They said they left me a little note here, Ms. Johnson. Just multiply by 4. Okay, fine. I'll check. So 5 times 4 is 20. 20 times 4 is 80. And 80 times 4 is 320. Yay! So far, this works really well. So if you don't have this on there, if you made a mistake, just go back and fix it. No harm, no foul, right? Okay, even include my little happy face. Just kidding. And then they put in this this form here. This is your exponential. This is your first term. Oh, I should highlight in orange or something. So your first term goes right there. That doesn't look like an arrow. You guys can all make fun of my arrows. Don't judge my arrows. Okay, and then this guy here, this is called your growth factor. Some people call it their multiplier. Some people call it your common ratio. And then it's going to be to the n-1. And then if I'm really trying to make sure that I'm getting an A on a quiz, or I really understand it, I would pick any of these random points and plug my answer in. Like what, Miss Johnson? So I'm going to plug this in. So I'm going to say 5 times 4 to the parentheses, oops, not that, parentheses, x minus 1. But I'm going to plug in a number, one of these. I'm going to plug in 3. My hope is that I get 80 out. If I get 80 out, then this is perfect. And I get another smiley face. And then I'm so excited. I plug in 3. I got 80. Look, I got 80. Yay. And then so I give myself another happy face because yay, both of these are right. Again, if you do not have this written on your page, get it on your page. I'm going to switch slides in 3, 2, 1. Okay, so, ooh, sorry, I didn't mean that. I meant this. Okay, lots more people doing more work. I love it. It says jumpstart 3 and 4. It says, I know 2 cubed times 2 to the 5th equals blank because blank. In general, 2 to the m times 2 to the n equals blank. So I already saw this. I thought you guys did fantastic. Let's see. Yes, this person says 2 to the 8th. Yes, yes, yes. So yes, it's 256. I don't care about it being 256. I more care about it being 2 to the 8th. Yes, ocho, muy bien. So 2 to the 8th. So if you wrote 256 or whatever, can you also put in there 2 to the 8th? Very good. Let's see. This person says because the base stays the same and you add your exponents. Very good. Okay, so here's some more proof in the pudding, okay? I'm going to tell you, if you ever get stuck anywhere, go back to your definition. What does 2 to the 3rd actually mean? What does 2 to the 3rd actually mean? What is 2 to the 3rd? Yeah, it means 2 times 2 times 2. So I'm going to write that. I'm going to write it like this because it's faster. 2 times 2 times 2. Okay. That's what this guy means right there. Okay. And then what does 2 to the 5th mean? I'll write it in purple. Yeah, it means 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. Bang. So Miss Johnson, she even had to count it. Do you see how more, like how long it is to write this? I'd say things like, oh my gosh, I wish there was a better way to write 2 times 2 times 2 times 2. You guys all see what I'm saying? And some of you are like, yes, Miss Johnson, there is a better way. It's called 2 to the 5th. Exactly. So if I collected all these 2's, how could I write 2 times 2 times 2 times 2 times 2 times 2 times 2 times? Is there a faster way? Faster way. Is there a faster way to? Yes. And you guys are like, Miss Johnson, it's right there. It's 2 to the 8th. So yes, it's 2 to the 8th. Fantastic. Why, Miss Johnson? Because there's 2's. Good. How many? 8. In Spanish? Count with me. 1, 2, 3, 4, 5, 6, 7, 8. Right? Very good. So this person says, hey, Miss Johnson, I think I could just add my exponents. And the answer is yes. This is an exponential property, exponent property. that you will see again later on. Okay, you will see this again and again and again, but specifically in integrated 3, we just went over this. So for those of you like, Ms. Johnson, do I really have to? Yes, just learn it. Just learn it. And again, your job is to learn how to learn. So yes, so the bases stay the same and you can add the exponents. Exactly. That's one of the ways you can explain it. I'm going to move on from this. Awesome work. I saw that. Okay, so here's what we're going to do today. You're going to explore the meaning of a fraction as an exponent. Say what? A fraction as an exponent? Ms. Johnson, I'm comfortable with like this right here. I'm comfortable with it. I'm comfortable with 8. I'm comfortable with the 3 and the 5. I'm comfortable with all that. Now you're going to tell me that we have fractional exponents. Yeah, and they mean something. Okay, so don't worry. I'm going to walk you through. Okay, how can you determine the values of an exponential function that occur between the whole number inputs? Since the domain of a continuous exponential function includes all rational, everyone say fractional. So fractional numbers, how do we interpret a fraction as an exponent? So say what? Yeah, so that's what, by the end of class today, that's what you're going to be able to do. Word. Okay. So in previous lessons, you've worked with context for continuous exponential functions, such as the decay of medication in the bloodstream or earning interest over time in a bank account. Since time is continuous, we need to start thinking about the numbers that fill in the gap between 2 squared and 2 cubed, like 2 to the 2.5 or 2 to the 5 halves, right? Fractional as an exponential function. These numbers are actually quite interesting. So we're going to do some exploring in this task to see what we can find about these in-betweeners. Remember, we didn't have in-between people, like 1.2 people didn't make sense, but there are points in between here that do make sense, okay? All right, so here's the next problem. It says, complete the following table for a geometric sequence recursively as f of 0 equals 4, 0, 4. This is this, right? And then it says, okay, now repeat this with me. In regular terms, this says, what is f of n? How do we say f of n in normal English terms? F of n and f of n minus 1. How do we say this? Next. Very good. Next. Next equals 2 times, what is this guy? What's f of n minus 1? Yeah, kind of. Okay. How do you say this guy? How do you say f of n minus 1? Who remembers? Yes, previous. Thank you very much. Flooding my little chat there. That's not how you spell previous, y'all. Previous. Uh-oh, I caught someone's I spelled wrong. Woo. Previous, is that how you spell previous? Me think so. So I'm just going to leave it. Okay, very good. Very good, very good. Okay, so translate that to normal people English here. So to get to the next number here, what do I do? What do I do here? To get to the next number, what should I do? Yes, multiply by 2. Very good. Muy bien. All right, so you want me to multiply by 2. So I go like this. This is Miss Johnson's little notation. So times by 2. What would I put here? As someone says, Miss Johnson, put what number? What number do I put? Yes. Very good. Go ahead and put it in yours. Everybody's telling me now. Very good. Very good. Put it in yours while I catch up with all of the stuff. Very good. Very good. Okay. So yes, Miss Johnson put 8. Okay, I put 8. Then can you fill out the rest of this table really quick? Fill out the rest of this table. Oh, en español también. 8. Very good. All right. So someone says, hey, Miss Johnson, I know how to do this. This is going to be 16. This is going to be 32. And this is going to be 64. Miss Johnson, where are you getting all these numbers? So first of all, someone told me in the chat. Second of all, I checked the work by multiplying by 2 every single time. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. Woo, woo. Okay. Everybody's okay with this, yes? Then write an explicit equation for the function. You guys all remember back over here in the jumpstart problem, you're just going to take your first term, not 0, 1, 8. Okay, so here's my function. So f of n equals, someone said 4 times 2 to the parentheses n minus 1. This is what one of your classmates said, not me, not I said the duck. And there's several of them, by the way. Shoot, not 4. Why I put 4? My bad. I put 8. 8. Is that right? Yes, that's correct. Sorry, it's 8 times 2 to the n minus 1. Someone else in the chat put this one. Someone put 4 times 2 to the n. And then the only way that I'm going to check this is I'm going to plug in some random guy, 3, and see if it works. So 2 cubed is 2 times 2 is 4 times 2 is 8. And 8 times 4 is 32. So this one also works, Miss Johnson. Yeah, and you can kind of see how they're related. If you really think about it, you can see how they're related. Very, very good. Very, very strong work there, guys. Okay, plot these points on the graph at the end of this task and sketch the graph of f of x. Okay, so I'm going to do that right now just so that we can do this. So first I want to include this table. So 0, 1, 2, 3, 4. Okay, and then I'm going to put my numbers in here as 4, 8, 16, 32, and 64. And so if I move this a little bit and make it smaller, there you go. You see some of my points right there? Okay, and then they also said to plot the function, or so to graph the function. I'm going to use this one because this is the one that you guys all see. If I plug in both, it really doesn't matter. This is x minus 1. Very good. What do you guys notice here? Someone say what they notice here. Yeah, they go through the points. Very good. It is exponential. Perfect. So we already plotted this, so now we're done with that. Let's continue. It says, we know a geometric sequence is discrete with a domain consisting of only whole numbers. Travis and Tahani, 2 inquisitive math students, are wondering what would happen if they decided they wanted this table to be just a few points on a continuous exponential function. Then they would create a table with more entries, maybe with a point halfway in between each of the points in the table above. There are a couple ways that they might think about filling up the half steps. So here's this whole thing, right? So Travis makes the following claim. If the function doubles every time it goes up by 1, then the half of the growth should occur between 0 and half, and the other half occurs between half and 1. So for example, we can find that x equals half by finding the average of the outputs of 0 and 1. Does that make sense to you? So going back here, looking at this picture, he's saying, in order for me to find the in between these two, I could just take the average of these two, meaning this plus this divided by 2, and it would be here. Okay, and let's see if that's true. So fill in the parts of the table below that you've already computed, and then decide how you will see the rest of them. Okay, so here, I'm going to fill these in. Help me, someone. Someone says, Ms. Johnson, this was 8, right? This was 16, 32, and 64. So what he's saying is, if you take these two and divide by 2, then you can find this part. So let's do that. What's 4 plus 8? So this guy goes 4 plus 8, go this way, divided by 2, right? And someone says, okay, 12 divided by 2. Well, that's just 6, Miss Johnson. Okay, and then I'd continue. 8 plus 16 is 24 divided by 2. Well, that's just 12. In reality, you're finding the in-between points, like literally the point smack in between. So 16 plus 32 is 48. So this would be 24. And then this guy here would be 32, 96, 45, 46. Oh man, help me. Help me, someone. 32 plus 64 is 96 divided by 2. So that's 45 plus 30. So 48. right? Is that right, someone? Okay. So then we did it. So now plot it also on the same task for problem 12. So I'm going to keep going back to this one. So someone help me remember these numbers. So just plot. Let me just take a picture of this. How about that? Okay. I'm just going to use this to fill in my table. All right, here we go. Let's go back here. Was it here that I did this? Yeah. Okay. So let me go here and fill in my table. So here, so if I did 0.5, I would get 6. And if I did 1.5, I would get 12. And if I did, you guys all following what I'm doing? You guys comfortable with this? 2.5, I would get 24. And 3.5, I would get 48. Okay. All right. So if I make this bigger, I wonder if these extra little points I got are on there. That's what we're trying to figure out. What do you guys think? Do you think that point is on our curve? What do you guys think? Do you think that point is on our curve? Yeah, right? Yeah, exactly. So you're leaning on what we did before? Absolutely. Good job. So comment on Travis's idea. How does it compare to the table generated in problem 1? For what kind of function does this work? Tahani suggests that they should fill in the data in the table the following way. I noticed that the function, okay, so what do you guys think? Do you think that looking at this, those extra points that we added, are they on the curve? That's what I want you to answer here. Do you think they're on the curve? If you say yes, say, I think they're on the curve because I see that the curve goes through those points. If not, say no. And kind of like think about, okay, well, what should we do next? So I'm going to give you a second to answer that. I'm going to pause this real quick. Okay, so you all said, Ms. Johnson, I don't think, I do think. A bunch of you have told me in the chat whether you think it is or not. Very good. Okay, so Tani suggests they fill out the table in the following way. I noticed that the function increases by the same factor each time it goes up by 1. And I think this property should hold over half intervals as well. So fill in the parts of the table that you've already computed in problem 1, and then decide how you might use Tahani's way to fill in the missing data. As in the table in problem 1, each entry should be multiplied by some constant factor to get the next entry. And the factor should produce the same result as those already recorded. Use this constant factor to complete the table. Also plot Tahani's data on the graph at the end of the task of this problem. Okay, so I think I should have, I'm going to go back and fix my table so my points show up in different colors, because otherwise it's going to be funny. So here's what they're saying. So here, this is 8, this is 16, help me, this is 32, and this is 64. Sorry for the messy, but I want you to get understanding. So here, what they're asking you to do, Tahani thinks that because this is, it's growing by a certain amount, then we should take this and figure out what number goes here using the same multiplier, right? So if 4 is missing, or like there's a number missing between 4 and 8, right? And you're multiplying by the same factor every single time, right? What factor would that be? Okay, that's what I want you to think right now. So go ahead and figure that out. Okay. So this next one here, and maybe I need to take notes. I'm gonna switch to my OneNote and see if I can do this both. Okay, so let me see. Okay, so we're in Explore 6. So let's go here. So here we are at this problem here, right? And we already know, we already got a bunch of numbers. We got 8, 16, 32, and 64, right? So we have all these numbers. Sorry, it's just going to take a second to catch up. So now what we're going to do is we're going to go back to the way we did our jumpstart problem, and we're going to figure out what numbers go in between, okay? So let me just catch this guy up. Oh, maybe it's not working. 2.4. Yep, it's working. Oh, there it goes. Okay. Sorry, Ms. Johnson needs to be more patient. So the way we figured out this number up here, just as a reminder, we said, oh, all you have to do, right? This is what you guys did. You said, oh, 320 divided by 5 equals, and we figured out it was 64. And then because you have 1, 2, 3 jumps and you want to multiply the same number, right? You want to multiply that same growth factor, common ratio, whatever you want to call it, by the same number. So that's going to be a multiplying 1, 2, 3 times. So then we think, oh, okay, so that number cubed, so that's that number right there, equals to 64. And you try a bunch of numbers and you're like, oh, Ms. Johnson, I know what it is. It's 4. So you're saying put a 4 in each of these boxes, Ms. Johnson? Yeah, right? So then 5 times 4, that's how you got 20. 20 times 4, that's how you got 80. And 80 times 4 gives you back to 320. So far, so good? Kind of. You guys are almost there. Okay. And if you're frustrated, good, because it means you're about to learn something. So someone said, hey, Ms. Johnson, can we divide 64 by 4? Sure. But that means we're going to take all these jumps. 1, 2, 3, 4, 5, 6, 7, 8 jumps. We could do that, or we could just do this jump right here, from here to here. So I'm going to be doing that little jumps just so my brain can like kind of calculate in my head. So let me scoot this over a bit. So do the math with me. Let's do 8 divided by 4. And you're like, Ms. Johnson, that's just 2. And I'm like, yep, it's 2. Very good. So now, because yes, you're supposed to be a little bit like lost right now. It's good. It's good. So how many jumps are there from 4 to 8? How many jumps are there from 4 to 8? Looky here, guys. How many jumps from 4 to 8? Yes, there's 1, 2 jumps. Yeah, my clock is wrong. Oh, it is time for us to go. Okay, let me just finish this. So here we have 1, 2 jumps, right? So I'm thinking, what squared gives me 2? What squared gives me 2? And it's not as nice as that other number, but it's okay. So instead of thinking about what squared gives me 2, I'm going to just write it as the square root of 2. Does that make sense? I'm just going to rewrite this as the square root of 2. So 8 divided by 4, 16 divided by, yes, 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 yes. So because there's 2 jumps, 1, 2, my multiplying factor is the square root of 2. So Ms. Johnson, what do you want me to do? So this times root 2 gives me that. This times root 2 gives me 8. This times root 2 gives me the next thing. Okay, so here's where I'm going to end, and I want you guys to continue. Can you fill in the rest of these numbers in between here to make sure that you have the rest of this chart? Okay,